Hi, I'm Ian, and this is the introduction video for the Week 3 proof assignment. The Week 3 proof assignment is actually a milestone, something you'll see in some of the other proof assignments over the course of this class, where you'll complete the first half or so of a project or program, in this case the meal price calculator, and then the next week, for us this will be Week 4, you'll complete that. So you don't have to worry about completing the whole thing this week, which is nice. So let's take a look at what the meal price calculator should look like. Just scroll down here to sample run of the program might look as follows. So it'll ask, what is the price of a child's meal? And then you can type in a number, how much a child's meal should cost. What is the price of an adult's meal? And then the user will be able to type in how much an adult's meal costs. How many children are there? How many adults are there? What's the sales tax rate in percent? And then once you've given all that information, it'll tell you the subtotal, the amount of sales tax, as well as the total that you should be paying. And then what is the payment amount? You should be able to type how much money the customer is paying, and then how much change the customer is owed. So we won't be worrying about this entire thing right now, because again, this is just a milestone, but this is the goal. This is what the program should look like when we're done. So the actual requirements for the milestone are to make sure we can get the user input, ask for the price of a child-adult meal, and store those values properly into variables as floating point numbers. So I'll talk a little bit about floating point numbers and integers, as well as strings, which are the three most common types of variables you'll see in Python, as well as many other programming languages. And so in a minute, I'll talk a bit about what type is and how that really is going to affect how you handle this problem and write your own solution for this project. The second requirement is to ask for the number of adults and children and store those values into variables as integers. And then same thing with the sales tax rate, and then compute and display the subtotal. And we don't need to worry about formatting or decimals or anything. We just need to get this information, do some math, and spit out a result. And then in week 4, then we worry about making it look pretty and actually doing things like calculating change and stuff like that. So before we actually get started on the programming part of this assignment, there are some concepts that I do want to touch on just to prepare you better for the actual coding part of this assignment. The first being type, which I did mention earlier. I just have this empty Python file up in VS Code. There's some comments, just the different things I want to talk about before we get started. And again, the first is type. Now, every variable in Python has a type, and it is what is inside of that variable. So you've seen variables before, and they have different types. For example, x is equal to 1. So that's a variable. Now x has the value of 1. But x also has the type of integer, and that is because 1 is an int, or an integer. Now if we put 1.5, now that's not an integer anymore, because integers can only store positive or negative whole numbers. 1.5 is what's called a float, or a floating point number. Numbers, positive or negative, that can have a decimal point and numbers behind that. Fractional, decimal stuff, those are called floating point numbers. So just remember that. And the last really common type that you'll see is a string. And this is probably the first type that you have seen in this class. That's a string. It's a string of stuff strung together. A string is a sequence of information, or a sequence of characters. And a character is anything from a number to a letter to weird stuff, anything you can type in on a keyboard pretty much. And hello world is one of those. Hello world 1 is a string. Hello world 100 is a string. But here's where things get complicated. 100 in quotation marks is also just a string. So allow me to explain. You can have x equal 100, but that 100 is a string. You can also have y equal 100, and that 100 is an integer. You can also have z, which equals 100, but that 100 is a float. And with variables, you can do math. So we can have w equals y plus z. And then we can print w to see what that is. And that works just fine. It gives us 200. But if we try and do y plus z plus x, x is 100, but it's not actually a number the way that y and z are. So if we try that, the computer throws a fit. So this is an important thing to remember, is that not all types can be used together in the same way. Strings can have numbers in them, but they themselves are not numbers. The other important thing is the input function, which we've used before. Input, say something. Now, this will get input from the user, store it in x, and then print x right back out. So we can type in whatever. Say something. Hello there. And then just says hello there back. So the problem here becomes when you need a number. And then we'll just x equals x plus 2. So we're just adding 2 to x. That should make sense, right? So if we say 4, we should get 6. Ooh, it threw a fit. The reason it did that is because the input function actually gives us a string, not a number. So it has no way of knowing whether we've typed in a number or a bunch of words or just complete gibberish. It could be a number, it might not be a number, and even if it is a number, it doesn't know that. So in order for us to do anything with input, if it has to be a number, we have to convert it. We have to change its type. Now this can be done through conversion functions. Now each of these three types has its own function that can turn one thing of another type into its own type. So if we need a number, we'll just use an int. If we need an integer, we can actually say int, and we can put our input inside that, so that our input gets converted into an integer, and then the integer gets stored into our variable. So now this should work. Give a number, 4. 6. It gives us 6 in response. That's exactly what we wanted. So that's just something to keep in mind, is that sometimes you'll have to convert types from one to another. And lastly, I do want to talk about format strings. So format strings are kind of fancy. So we just say x equals 27, print x, it gives us 27. But what if we wanted to give a little bit more meaning to that number? I want to say there are x amount of apples in my fridge. If we try and do that though, it'll just say there are x amount of apples in my fridge. X, even though it's 27, how are we going to actually put 27 in what we're trying to print? We can do this through a format string. So you just take a string like this, you put the lowercase f in front of it, and now inside your format string, you can put curly brackets. And inside the curly brackets, you can actually put code instead of just more string. So x right here actually gets inserted as its value and not the letter x. So now if we try this, it says there are 27 amount of apples in my fridge. A perfectly grammatically sound statement. So the thing with format strings is they don't necessarily have to be just a value itself. You can also say x plus 1, and so then 1 will get added to x before it gets put inside your format string. So now say there are 28 amount of apples in my fridge. You can even have multiple pieces of code in your format string. So I can say y is equal to apples, and then I can say there are x plus 1 amount of y in my fridge. If I run that now, it still says there are 20 amount of apples in my fridge, but I can change this to cheeses. There are 20 amount of cheeses in my fridge. This is a programming class, not an English class. So now let's take a look at the stuff that we actually need to do for the assignment. The instructions are here. Just gives us a little reminder about type. Need to pay attention to that. First, we need to ask the user for the following. We know how to ask the user for stuff. It's the input function. So we can just have a variable equals input something. That's how we would normally do it. So we need the price of a child's meal. So we could call that variable something a little bit more descriptive, like child price. The price of a child's meal specifically, and then we can change the input prompt to something a little bit more descriptive, like what is the price of a child's meal, and then whatever we type in will get put into child price. The thing though is that it needs to be a floating point number. So this is where we can use those conversion functions that I talked about earlier to take the string that input gives us and change that into a float, which I know how to spell. So now what happens is it displays this prompt. The user types in a number, which is a string, and that string that has a number in it gets converted into an actual number by this function here, gets turned into a floating point number, and then that gets stored finally into the variable so we can use it for later. So that's the first one, but we also need the price of an adult's meal, the number of children, the number of adults, and the sales tax rate. So we need maybe an adult price variable. Of course, variable names can be whatever you like. Having a variable name that is a bit descriptive of what is inside of it is good practice. And of course, we want a sales tax rate, something like that. Of course, the adult price needs to also be a float. Child count and adult count need to be integers, so you'd use the int converter on them. And sales tax rate is also a floating point number, so you want that. Next, we need to complete the following steps. Determine the meal subtotal before adding sales tax by multiplying the number of children by the price of their meal, multiplying the number of adults by the price of their meal, and then adding those two values together. So then the next step, you do some math here. So subtotal would normally equal the actual math, but in this case, we're just going to say the subtotal is 1, 2, 3, just so we can test out the final part of the assignment, or the final part of the milestone, which is to display the subtotal. So we can print subtotal. So now when we run this, it says what is the price of a child's meal? $600. Pay up. And then it just says $123 back, because that's what the subtotal is, and it doesn't actually do anything with the child's price right now. None of that has to do with what's being displayed on the screen. So it just displays 123. Now, 123 on its own, just a number, isn't really that descriptive. It's just a number. And we only know what it means because we're the ones writing the code. So if we want to make this a bit more pretty, we could say the subtotal is and then we could put the subtotal there. But how would we do that? Well, with a format string, like we talked about earlier. You can put the little lowercase f in front of the string, and then you can put the subtotal in there. So now, what is the price of a child's meal? 0. Doesn't matter. The subtotal is 123. So that's great. We can do stuff like add a $sign, which might make it prettier. So now it's $123. That's great. Of course, it's only displaying 1 decimal point, which isn't how we want to display money. But we'll worry about that next week in the second half of this assignment, because right now we don't have to worry about that. All we have to do is get this information, do some math, store it in the subtotal, and then display that subtotal. And you do that, you should be good for the milestone. That's what you'll need to do for this week. If you have any questions, ask your TAs, ask your professors, and good luck. You got this.